you can get it from, they have two cases, air flowing parallel to the material, or case 2, right? That is how to find the H. And then you also know that you have other parameters, for example, like the latent heat, or latent heat, of course, at T wet bulk, TW. So that's why I just reverse, okay? I make it reverse, and then we go to the previous slide that introduced to you about the humidity, about the latent heat, not the latent heat, the humid heat, humid volume, and so on. And now we're going to move on to use this humidity chart, okay, because you already know about this humidity, okay, dew point, humid heat, humid volume, and so on. And to get the humidity, you can use the equation of 18 divided by 29. So go back to here. So this is the equation. Where is my pen? Here. Okay, this is the equation. Okay, if you want to find the humidity using the equation, or even saturation humidity or percentage humidity. Okay, alternatively, alternatively, we can get the humidity using the humidity chart. Okay, so we're going to learn here. Okay, today what we're going to do is we're going to learn how to read this humidity chart and how to find certain parameters. For example, the humidity, the T wet bulk, the temperature of dry bulk temperature, the percentage humidity. So a few things that you can get from this humidity chart. All right, and after that, I'm gonna go back to the calculation involving the convection. Okay, whereby you have to find the RC, and then later on you can find the time. Where you consider only convection, and later on I will expand the equation to include radiation and also conduction, and then we'll be finished. Okay, that is for today. And then next week, Dr. Sharida will continue on a little bit on the application. For example, you have a full range of tray dryer, or you have pack bed dryer. So what is the calculation, the equation that you can use to calculate straight away the time for drying, for example, all right, and the rate of drying. So she will discuss about that. Okay, so humidity chart. So this is very important, okay, how to find the humidity without using equation. You can use the graph, because remember, to find humidity, you need to know the partial pressure. Normally, partial pressure is not given, all right? If not given, you're going to start. So you thought that you can use only equation, but in fact, you can use the humidity chart. Okay, I'm so sorry if my voice is not really clear today, because I'm having a little bit of sore throat, all right? So maybe you hear a little bit like not like the previous week, right? So I cannot push too much, because I afraid that it's gonna hurt my my throat later on, because I also have another class in this afternoon. All right, so let's say you are the dryer. So let's say this is your dryer, and then in this dryer, if you measure the temperature, so let's say this is your thermometer, okay, and you measure the temperature is 60 degrees Celsius. So this thermometer temperature, the temperature that they gave, is basically also called dry bulk temperature. Okay, sometimes, okay, normally people will just say the temperature of that room is 30. So you can also say the dry bulk temperature of that room is 30. It's the same. Okay, so when you come across with dry bulk, then you know that dry bulk is basically the actual temperature of that room ke ataupun whatever lah. And a dew point, here they already give you a dew point, is 26.7. So here need to determine the humidity. HP, CS, it has its humid heat, VH the humid volume. Okay. So here the humidity chart, okay, you see that here you have temperature, the y-axis, the x-axis, and the y-axis is basically humidity. So this humidity can be can be HW, can be you have HW lah, normal H, okay, you ada H, you ada HW, and so on. Normally ada dua tu yang you akan pakai. And here you see this a curve is basically we call it percentage humidity. Okay, so this line is basically where lay down the percentage humidity, all the percentage. So here 100%. So 100% humidity means what? 100% humidity is meaning that you are at saturated air. Okay, 100% humidity is saturated air. It's already saturated. So that's why humidity is 100%. So when people say about the saturated air, meaning it's understood that it's 100% humidity. Percentage humidity is 100%. So no need to say 100% to mention again. If they say that saturated air, no need to mention the percentage because it's understood it's 100%. Okay, and you have another line here. We call it adiabatic saturation curve line. So you see that the line here is not, it's linear, but they have certain gradient. Okay, so this one kita akan tengok later. Okay, this one later on, right? So now dengan information yang kita ada ni, how to find the humidity? Okay, first, since kita ada dew point and kita ada dry bulb temperature. So kita tengok dew point. Dew point 36.7. So you need to draw one vertical line. Okay, now you have to listen carefully how the method how to find humidity using this humidity chart. Okay, this is the simplest one. Nanti kita akan introduce benda lain yang akan menggunakan adiabatic saturation curve pula. Okay, so you ada 26.7. You just draw one vertical line. Of course, maybe some of you asking us where we should stop because you have percentage here, right? So because it's dew point, remember that what's the meaning of dew point? Tengok balik, dew point tu apa? So this is dew point. A temperature at which a given mixture of air and water vapor would be saturated, or temperature at which vapor begin to condense. Temperature vapor start to condense. Vapor tu gas jadi liquid. So meaning that you are at this saturated air condition. Saturated air condition meaning that you are at 100% humidity. So very simple. Okay, so apa yang kena buat? Vertical line stop sampai dekat 100% kat sini. Line 100%. Dia boleh je cakap unsaturated, dew point, unsaturated air condition 40%. Then you stop dekat 40%. But in this case, it's not mentioning anything. So just say dew point. So meaning that it's going to be 100%. And use your ruler. Plot one, draw one horizontal line to your right side. So this is going to give your humidity value. So it's going to be like 0.022 probably. Kilo water, kilo H2O over kilo dry air. Tengok dia punya unit. Okay, be careful with the unit. You need to write it down. Okay, this is simple. Okay, kita try another one. You may try. Please open up your textbook. Buka humidity chart ni. Buat terus exercise. Okay, do not just watching me. I'm doing this. So thought that, okay, it's very easy. I understand it. No. Please. Make your hand dirty. Do it. Okay, do it. If you don't do it, you will get lost later on. Bila you buat revision, you pun tak ingat ni. Macam mana dapat ni? How to get this one? I dah forget lah. I dah lupa. Right? So kita try another one. Let's say you punya dew point. Yang ni saya akan point out siapa-siapa untuk jawab. Bagi saya jawapan. Let's say you punya dew point is about 60 degrees Celsius. So what is the humidity value? Saya bagi you 2 minit. So hari ni kita buat practical sikit. Okay, like the last 2 week class, we did practicality on the plotting the drying curve. Pasal apa I insist you to do it because at least to expose to you to make to draw the graph faster. Kalau dalam exam ada graph, 2 graph sekali. Kalau you slow nak dapat point tu nak exactly 86.7222. Okay, tengok dekat kotak dia mana 7222. Memang lambat lah you plot. 86.722. Ambil je 86.7. Dah cukup plot. Okay, approximate je. Dah. That is the way. Yang penting you dapat dia punya pattern tu nanti. So once you dapat pattern, and then you gonna draw line for your area and so on. That one I will refer to your graph. How accurate your graph. Ada lain sikit tu okay lah, fine. Still fine. You still there. So you still get marks. You're gonna get marks for that. So I don't want the point like exactly 87.722 and then you buat 722. You pun tak tahu tepat tak tepat. Okay. So, okay, dew point 60. Berapa jawapan? Can someone help me to answer this? Ada tak jawapan ini? Ada. Berapa? Saya nak panggil ni. Saya tak suka panggil. Kalau you suka vote.
0.13.
0.13. 60 dew point 60 degree Celsius. Okay, thank you very much. It's okay, walaupun jawapan betul ke salah ke, don't worry, you try, okay? Sebab nanti you akan belajar balik. Kalau salah. Okay, so 60, kita tengok kat sini
Doktor 0.15.
Nak betulkan balik? Okay, betul jawapan dia. Okay, thank you. Alright. So you tengok draw kat sini 60 degree Celsius dew point Sekarang ni kita cakap pasal dew point. If you have information of dew point. Sampai ke atas ni 100%. Oh, senang dia sampai atas ni. Tu 0.15. Right, that is the answer. Kalau yang you kena dew point yang yang dah terlebih kat sini, you kena lebih kurang lah extrapolate dia punya graph ni. Macam tu lah lebih kurang. Right? Tapi normally dew point takkan sampai higher than that lah. 60 tu dia, that is maximum. Right? Okay, that is kalau you ada dew point. Let's say dia tak bagi dew point. Macam mana nak buat pula? Tak ada dew point. Okay, kita tengok ni kalau dia tak ada bagi dew point, so you kena ada dry bulb temperature kena ada. Okay, dry bulb kena ada, wajib ada. Dan you kena ada lagi satu parameter lain. Barulah boleh dapat. Apa parameter lain? Okay, saya kena bagilah contoh. Contoh lah, let's say you ada okay, benda pemadam. Okay, you ada dry bulb temperature. Let's say temperature you adalah 80 degree Celsius let's say. And another parameter maybe I boleh bagi percent humidity. Okay, percent humidity, let's say I give about 20%. 20%. So from here, from this, you can ada dua parameter ni. Kalau you ada dew, you just remember kalau you ada dew point, just dew point enough untuk dapat humidity. Cukup. Tapi kalau you ada dry bulb, temperature tak boleh. Sebab you imagine katalah ni 80 degree Celsius, you ada dry bulb, you draw satu line. Okay, you draw ni sampai bila you nak berhenti ni? You don't know. Kat mana you nak guna berhenti? Dia tak ada stop point. Dia tak ada intercept point dia. Okay. So maknanya dry bulb ni kena couple with other parameters. So dalam kes ni saya couplekan dengan humidity. So let's say my humidity is 20%. Okay, mana line 20%? 5, 10, 20 and so on. This is 20%. So you draw line ni, okay, kat sini dia akan intercept. Okay, line yang 20% ni. So yang intercept ni, barulah you pergi ke kanan you untuk dapatkan humidity. So it's about 0.1 maybe 1.108 ke. Okay. Dia punya tu kg H2O over kg dry air. So this is dia punya humidity. Boleh faham? Ada orang nak tanya? Tak perlu repeat kan? Okay. Alright, so this is kalau ada dry bulb temperature kena ada another punya parameter lah untuk dapat humidity. Okay, kita try satu lagi. Let's say I give you humidity. Okay, ni tolong volunteer. Let's say I give you humidity 0.07 kilo water over kilo dry air. So what is the T dew point? T dew point. Apa T dew point? Boleh tak seorang? 2 minit. Okay, siapa boleh tolong?
$47 macam tu.
Okay, 47. Okay, kita tengok kat mana. Thank you tolong tu. Okay, 0.07, you draw satu horizontal line. Senang je kalau ada nak dapat dew point. Senang je. Dew point humidity ni, you pergi kat sini. Lepas tu, you pergi kat bawah ni. Ni berhenti dekat 100% kan tadi kan? Sini kan? So, you dapat 47 something. Okay, thank you very much. Yang jawab tadi betul lah. Sebab dia, you tengok balik konsep yang nak dapat daripada dew point ni. Konsep dia sama. You naik atas, you pergi ke kanan, you dapat humidity. So, sekarang ni you ada humidity, you patah je balik. You reverse je. Simple. Dia tak ada trick. Okay, this one tak ada trick langsung. So, dia tak challenging pun. Alright, now macam mana kita nak dapat? Kita dah dapat humidity tadi 0.022. Now you want to get the HP, percentage humidity. Okay, ingat percentage humidity ni bukan jawapannya 100%. 100% tadi dekat dew point. Dew point temperature you 26.7. Yes, is 100% percentage humidity. But now you kena ingat your dryer actual temperature adalah 60 degrees Celsius. So what the percentage humidity at that 60? It's not 26.7. 26.7 is dew point. The dryer don't have the dew point of the condition of the dryer is not 26.7. It's 60. The 60 tu dew point dia adalah 26.7. You kena faham lah. So now dryer to 60 degrees Celsius, what is the humidity? Okay, so kali ni you can ada dua. You ada dew point. This is dew point. You berhenti you still dekat 100% ni. And then you have another one, 60 degrees Celsius. Your dry bulb. So what happened? Daripada dew point ni, you draw one horizontal line. Dia akan meeting dekat 60 tadi. Dry bulb. So yang intercept ni, antara dua ni, okay, you tengok dekat percentage humidity. So it's between what? 10% and 20%. So it's something like here, in between. So that could be 60%. So bagilah jawapan you 60% ke 70 ke. So ikut rasa you lah. Tapi as long as dalam range 10 to 20%. Dan logik. Okay, boleh? That is the HP. Okay, kita cuba another one. HP Let's say you punya dry bulb 80 degrees Celsius. Dew point is 40. What is the percentage humidity? Try buat. Saya cubalah. Okay, 60, sorry. 80, you draw satu vertical line. And then you have another one, 40, you draw another line. This is dew point. Dew point sampai 100. You berhenti kat sini. And then you draw satu horizontal line. Dan meeting dekat you punya dry bulb, 80 degree. So this one is between 5 to 10. So probably you akan bagi 8 ke 8% atau terpulang. Alright. So this is how to get the HP and CS. CS dengan VH, you patah balik dekat equation ni. Humid heat, masuklah humidity yang you dapat tu. Get the CS. Humid volume, VH, masuklah nilai humidity dengan temperature dalam bentuk Kelvin. So you get the VH. So this one you cannot get from humidity chart. Okay, it's a true equation. So no need to remember equation. It's an open book. Even it's open Google, you boleh pakai Google. So but don't worry. Starting this semester, untuk final exam, even online, kita akan pakai Safe Exam Browser. Kita ada pakai satu yang baru. Safe Exam Browser ni, bila you buka je benda lain, dia akan detect. Tetapi you tak boleh buka benda lain. You freeze untuk buka benda lain dalam you punya laptop ataupun komputer. Yalah, nak Google lagi. So fokus jawab soalan. Ni kau tak fokus Google. Okay, so that's on the CS, VH, H and HP, okay. Ni kalau you ada dew point. Okay, now kita tengok dalam adiabatic saturation temperature. Ni kita panggil TS lah, kalau nak dapatkan nilai TS. And then this one, adiabatic saturation temperature ni, kita akan pakai yang ni, line ni, adiabatic saturation curve line. Macam mana nak guna that line untuk dapatkan temperature, humidity and so on. Alright. So yang lain-lain ni I don't want to talk about it because it's like the how they run experiment and so on, and then they get they reach the adiabatic saturation. You know what is adiabatic? Adiabatic ni you belajar dalam reaction adiabatic. So meaning that the entering gas mixture and leaving is in equilibrium. There's no heat transfer, mass transfer. So it's in equilibrium condition. Adiabatic. Okay. So kalau tak faham juga, Google adiabatic. You all kan suka Google kan, adiabatic, what is the meaning. Okay, so for this adiabatic, kita akan pakai adiabatic saturation curve line. How to find the properties. Okay, so this is basically equation yang dibuat untuk plot. Dia plot ni lah, plot line-line ni dekat situ, guna this derivation lah. Alright. So example kita pergi example terus. Macam mana nak guna that adiabatic line. So kalau tadi okay, kalau nak tahu beza dia lah, beza dia yang ni dengan adiabatic, apa beza dia? Okay, kena ingat kalau yang ni yang kita baru lepas this one yang kita I just explain to you how the method how to find those maklumat. It's basically you ada dryer and then you ada air. Adanya air yang masuk dalam dryer ni. So you ada temperature, you ada dia punya dew point. Alright. So kita nak tahu properties lain dalam air yang dalam ni, incoming. Okay, air ni atau incoming ataupun dekat outlet ni. Katalah outlet. Outlet ni dia bagi temperature, dia bagi dew point and so on. So kita nak cari dekat that particular stream. Okay, this particular stream kita guna kaedah yang tadi ni lah, yang simple ni, yang senang. Okay. But bila kita nak cari, bila kita nak mencari when we want to find, let's say this is dryer, and then kita ada air yang supply, yang coming, dia adalah temperature dia, humidity dia yang masuk. Okay, but in this case, kita nak predict yang keluar ni, air yang keluar outlet ni, what is the temperature, what is the humidity and so on. Kita nak predict this part. Okay, kita tahu properties ni, but we want to predict that part. Okay, dan kita akan pakai this adiabatic saturation curve punya konsep. Boleh faham? Okay, apa beza dia dengan yang ni, yang kita baru lepas ni? Yang kita lepas ni, kita just nak cari particular stream ni je. Stream tu apa properties dia punya air. Dan kita pakai yang method yang ni lah, yang kita baru lepas ni. Tapi, when we want to find other stream, maknanya stream yang ni, dia ada properties dia, tapi kita nak tahu stream yang satu lagi, nak predict. Dan kita pakai adiabatic saturation curve punya method. Okay, example example. Okay, I nak tengok balik example ni dia tulis apa. Air stream 87.8, humidity 0.03, contacted in adiabatic saturator. Not necessarily dia akan cakap you ada contact dengan adiabatic saturator ke tak untuk dapat kaedah untuk gunakan that adiabatic saturation curve line method. Not necessary. This statement, this keyword not necessary to mention. Alright. And it is cool and humidified to 90% saturation. Okay. Dia 90% dia saturation dia, bukan 100%. So dia tak reach lagi saturated lah. 90% ni tak reach saturated. So what is the final value of H and T? Alright. 87.8, 0.03. So dia macam ni lah. You ada dryer. So you ada incoming air. Temperature dia 87.8. Humidity dia adalah 0.03. And then dia dah in contact dalam dryer, dia keluar. So now dia ask you to predict what is the temperature and humidity outlet. Ini kena guna adiabatic saturation curve method. Okay, ni listen carefully macam mana nak guna. Okay, first you ada maklumat dekat sini, nak predict dekat sini. Alright. So you ada 87.8, mana 87.8? Okay, this one 87.8. Draw one vertical line. This is 87.8. And then the humidity is 0.03. So you have this one, humidity. Draw one horizontal line until you intercept with that point. Okay, point yang dekat 87.8 tu. Okay, now you have to listen carefully. Okay. Since kita akan guna adiabatic saturation curve pasal kita nak predict other stream. So you tengok adiabatic saturation curve lain yang mana yang which one is nearest to that intercept. So you ada this one, you ada this one. Ada 2 point lah. Ada 2 line. Line atas ni jauh sikit. You ambil line bawah. So kenapa nak kena identify? Why you have to identify that line? It's basically you kena draw nanti satu line. Okay, you kena draw satu line. So this line, dia punya sudut dia adalah sama dengan sudut sedia ada yang dah ada draw line ni. Okay, maknanya you kena draw satu parallel line lah. Okay, yang melalui intercept tadi. So, ini saya just draw kat sini. Tapi sebenarnya kat sini lah. So, you tengok yang bawah ni, paling the easiest way is that you tengok line bawah ni adalah yang paling dekat dengan point tu. You ambil you punya pembaris, take your ruler. Okay, this is your ruler for example. Okay, and then move little bit near to that point. Let's say this is your ruler yang follow line yang bawah ni, adiabatic saturation curve. And then you move up little bit until ruler akan cross that line. So what happen? You kena draw satu line. Just maintain position of your ruler tu. Bila you dah naikkan ke atas, you maintain pasal you nak draw satu line yang parallel dengan adiabatic curve line kat bawah ni. So you pun draw lah satu line. Okay. So this line draw sampai mana-mana lah. Okay, so this basically line ni parallel dengan yang bawah ni. Sambung. So kat mana nak stop sini? Okay, dia cakap dia adalah humidified hingga 90% saturation. So you berhenti dekat 90%. Sebab dia cakap 90%. So when you reach that 90%, you go down. So this is going to be your temperature baru kat sini. Let's say I put 2, ni H2. So this is going to be T2. Okay, and then to get the humidity, draw one horizontal line that go to your right side. So this is going to be your H2 lah. So the answer going to be like 42.5 degrees Celsius. For example, this one is going to be 0.055 or 54. Okay, boleh? Okay, kita try another one. You kena try. That's why I mentioned you kena try on your own. Kalau tak, you tak faham. Let's say I had a dryer. Incoming temperature, I would say 70. And my humidity, I would like to have like 0.05 humidity. And this is humidified until 100% saturation. Sampai 100%. So what is the T2 and H2 out there? Cuba buat 2 minit. Nanti someone share me what is temperature, another one share me what is the humidity. Okay, ada orang boleh tolong saya? What is temperature? Tak ada. Saya petiklah nama. Okay. Panggil nama. Okay. Apa yang kena? Apa yang hilang? Okay. Li Wei Po.
Yes, doctor.
What is the temperature? What do you get?
It's around
More or less. Okay, approximate. Around?
I don't know, doctor.
You don't know?
I find intercept.
You don't know? Ayo, you don't know ah. Okay, sini. 70. One vertical line. And then humidity 0.05. Here. Apa interceptnya tak dapat. Ni intercept sini, intercept. Ni. And then 100% Okay, so this is intercept point. So mana yang dekat? You ada atas ni dengan bawah ni. Adiabatic saturation curve line. So yang atas ni lah you pilih. Ambil you punya pembaris tu, ruler. Okay. Trace dulu line tu. Lepas tu turunkan ke bawah sikit. Jadi you punya ruler tu kat situ. Maintain the same gradient here. Here ada degree ni. And then draw satu line yang parallel until 100%. So this is 100%. Okay, did 100% from bawah, you get something like 42 or 43. Okay. And then go to your right side. This one you get 0.035 of the humidity. H, right? So here, when they are humidified at 100%, okay, kalau dia kata dia humidified 100%, kalau tadi nak 90% kan, so you letak T2 H2 lah boleh letak. Tapi bila dia humidified to 100%, you boleh tukar daripada T2 H2 ni kepada, dia panggil juga TS dan juga HS. Pasal dia dah resaturated, 100% ni saturated, so you boleh jadikan ni sebagai TS dengan HS. Simbol yang lain lah. Boleh dikenali sebagai also known as TS and HS. So sini dia jadi SS, TS. Pasal dia are at the saturated. Okay, so that is for ni lah. So sama juga case dia. Let's say question dia tanya, dia bagi dekat outlet. Let's say dia bagi outlet temperature dengan humidity. So dia suruh cari dekat sini pula, kat belakang, kat depan. So you buat reverse lah. Reverse kat sini, pergi sini, patah balik sana. Kaedah sama. The method is the same. Okay, let me show you one example yang dia reverse. The reverse meaning that tadi you have dryer, and then they give information dekat sini, temperature dengan humidity yang masuk. But now they give you the outlet. Let's say the outlet ni adalah T2 ni temperature dia let's say I would say that is about, let's say like 30 degrees Celsius. Okay, yang keluar. So humidity kat situ humidity maybe around dia kena sama 30 0.03. Alright. So what is this one? Temperature dengan humidity kat sini. So you kena buat terbalik lah. So you kena start dekat belah sini dulu. Kat belah sini. So 30 degree Celsius kat sini, naik atas. Sebab there's no way that tadi you buat 80, 0405, you pergi sana. Now tak boleh. Kalau you buat sini, masuk sini, you nak pergi mana sana? Sana dah tak ada graph dah. Sebab tu you kena reverse. Okay. No matter how, you kena reverse. Alright, so now you ada 30 degree Celsius. Alright. Assuming that 100% humidified lah. And then 0.03. Ni 0.03 ni. Dekat sini. So now, you cari yang mana dekat adiabatic curve line. So this one yang paling dekat, nearest. So you kena draw satu line ke bawah. So ambil ruler you. Okay, ruler you yang sama line. You naik atas sikit. And then that ruler, move to that point. Draw one bawah point. Okay. Okay, draw satu line. Sini. Okay, sampai mana? Okay, sampai mana? Basically, bila dia bagi dekat belah sini, dia bagi outlet, you need to know another parameters. Whereby, at least dia kena bagi temperature kat sini. Ataupun humidity. Salah satu dia kena bagi. Okay, one parameter you need to know here. Untuk dapat yang humidity. Contohnya. Okay, kalau kata dia bagi temperature is 60 degree Celsius. So you akan, this line bertemu dengan this vertical line. So you dapat intercept. Daripada intercept tu, you baru draw satu horizontal line to your right side. So dia akan bagi 0.018, let's say. So this is the humidity yang masuk dekat sini. Okay, this is reverse lah. Kalau dia bagi yang outlet, cari yang inlet. Okay, ada soalan? No question, right? You pun tak tahu you faham ke tak. I hope you understand why you need to do it. Okay. And another one, okay, this is wet bulb temperature. Okay, ingat tak dalam constant rate you ada RC equal to H T minus T wet bulb. Now kita nak dapatkan ni T wet bulb. So how to get that T wet bulb? Okay, T wet bulb ni basically dia menggunakan kaedah yang sama. They use the same method of using the adiabatic saturation curve line. Dia guna method yang sama. So let's say kita tengok example ni. You ada dry bulb temperature 60 degree Celsius. It's passed over a wet bulb. So the wet bulb temperature, dalam kes ni dia bagi wet bulb temperature 29.5. And then dia minta you cari what is the humidity. Okay, tak apalah, kita tengok dulu example ni. Nanti kita tengok, saya akan create another example lain so that you can get the wet bulb. Okay, dalam kes ni, untuk cari wet bulb ni, okay, untuk wet bulb, dia jadi macam yang the first case you dapatkan humidity, whereby you ada dryer, okay, and then you ada air yang masuk, air incoming 60 degree Celsius, and then di wet bulb dia bagi tahu 29.5. So dia minta you cari what is the humidity here. So basically dia nak cari properties yang satu stream. Dia bukan nak cari other side. Okay, tapi nak cari other side, you akan guna adiabatic curve line. Tapi in this case, bila you want to find the T wet bulb, sebab T wet bulb dia punya properties is like adiabatic saturation punya properties. So that's why method nak dapatkan TW, T wet bulb, sama juga menggunakan adiabatic saturation curve punya method. Okay, kita pergi tengok 60 dengan 29.5. 60 degree Celsius, 29.5 is T wet bulb. What is the humidity? Right? So 60 degrees Celsius here, one vertical line, 29.5 is somewhere around here. Right? So bila dia cakap wet bulb, bermakna dia dekat keadaan 100% saturation. So dia akan pergi dekat atas ni, berhenti dekat 100% ni, 100% saturation ni. So this is T wet bulb, this is T, alright, 60. So what you need to do next is, because dia pakai adiabatic curve line ni, Yang T wet bar ni you kena tengok mana yang paling dekat line. So this one yang paling dekat lah dengan point ni. This point. So draw, okay, ambil ruler you, make sure that dapat the same gradient, and then go to that point and draw one parallel line dengan yang tadi tu lah, yang paling dekat tu, dia parallel. So you akan ada intercept kat sini, intercept dengan dry bulb temperature. From the intersection, then you go horizontally to this side, you get your humidity. It can be like 0.015, let's say. So this is your humidity. Okay, this is another way how to find humidity by knowing the wet bulb temperature. Tadi kita tengok dew point kan. Ini kita tengok T wet bulb. Okay, cuma method dia kena pakai adiabatic curve line lah. Dia kena turun dulu, and then baru terus tadi. Okay. Kita tengok another example. Ini you boleh try lah. You boleh try sekarang. Let's say temperature, dry bulb temperature of the dryer is 50 degrees Celsius. And humidity, okay, ni you ada humidity macam ni nak dapat T wet bulb. Tadi example dia dah bagi T wet bulb, ni kita nak dapatkan. Pasal dalam equation yang constant tu you ada TW, you kena determine. So kita buat example yang kena determine T wet bulb. Dia dah ada T wet bulb. And humidity let's say is around 0.03. Alright, so what is the T wet bulb? Okay, ni yang biasa yang akan pakai nanti dalam calculation. Okay, dah ada 50. So this is 50. Alright, draw one vertical line. Humidity is 0.03 here, 0.03. One horizontal line, and then you meet up here. So that is the intercept point between the humidity and also the dry bulb temperature. So now you cari yang mana yang adiabatic curve line yang paling dekat. So this one yang paling dekat. So ambil ruler, pergi sana, trace line tu, and then draw satu line sama parallel sampai dekat 100% kat sini. So daripada situ, from here you draw one vertical line ke bawah. So this is going to be T wet bulb. So it's going to be like around 23 degrees Celsius, about that. Okay, boleh kan? Okay, kita try another one. This one you yang try, not me. Let's say you ada dryer, temperature masuk T adalah 80 degrees Celsius, right? And you punya humidity is around, yang masuk tu around, let's say 0.04. Okay, find the T wet bulb. What is the value? Okay, try. Cari 2 minit for you to find it. Okay, siapa dah dapat? What?
42.
42.5. Okay, thank you. Okay, tengok 80 degrees Celsius, one vertical line, and then one horizontal line for humidity here. You get intercept here, more or less. The nearest point is here, nearest line. So draw one ambil ruler, naik atas sikit, then draw that line, sama gradient, berhenti dekat 100. So, dari sini you turun bawah. Alright, siapa yang jawab tadi? Correct, thank you very much. So, you get the T web bar. Okay? So, seems like you, all of you really understand how to get it because it's very important. Alright, so then kita dah habislah those parameter web bar, adiabatic and how to find it. Moisture content kita dah lepas dah. Alright, now I go back to, ada soalan tak yang tadi yang guna humidity chart? Kalau ada soalan, tanya sebelum I move to this, back to the constant rate period using equation yang convection. You kena fahamkan betul-betul humidity chart macam mana nak dapatkan nilai dia. Tetap open for question now. Okay, it's okay, tak ada soalan. Alright, so now I recap again. At the constant rate period, considering that you are having the convection only, kita dah buat establishment the equation. So to find the RC, you boleh pakai equation H equal to T minus TW divided by latent heat W. So kat sini you ada T wet bar. Itu tadi dah saya dah ajar. I already teach you how to use the humidity chart to get this T wet bar. It's very important. Once you know the T wet bar, then you boleh cari latent heat dekat wet bar temperature. Let's say you determine T wet bar is about 40 degrees Celsius, and then you can go to your steam table to find the latent heat at 40 degrees Celsius. Okay, dia kena correspond kat sini. Sebab tu saya cakap is very important. Okay, yang lain ni okay je. Heat transfer coefficient, okay, like this one dia dah expand je. Expand je. Expanding you ada LSA X1 minus X2. Okay, untuk H ni, to find the heat transfer coefficient, dia ada bagi case 1, air flowing parallel, so you can use this one. If this is all the condition comply, alright? Or if air flowing perpendicular, so you can use this equation. If this equation comply, okay? So let's say kita tengok example ni. Macam mana dia gunakan, how this example, they use all the equation like humid heat, humid volume, determine T wet bar, and so on. Ni dia comprehensive dengan yang kita baru tengok tadi, parameters tu. Barulah you dapat boleh kaitkan, you can relate. Okay, because I go first on the equation, you met that parameters, and then barulah I discuss what is those parameters, how to get it. Is rather than maybe it's easy for you to remember compared to the previous method. I just just discuss all those parameter, and later on mungkin another week baru jumpa equation. So mungkin dah lupa masa tu, right? Mungkin already forget about it. Okay, let's say you ada granular material dry dalam pan. Okay, this is your pan, for example. It's a tray dryer, I think. So that is size 0.45 times 0.45. So basically that is basically dekat base ni lah. 0.457, 0.457, and this is 25.4. So dalam drawing, important adalah area. So volume is not important, alright? So material is 25.5 depth. So maknanya dia dah cakap semua ni occupied lah with that material. Side and bottom consider insulated. Maknanya side, belah side sini dengan bottom insulated. Maknanya tak ada heat transfer dekat tepi dengan bawah. Only dekat top. Sebab tu area je. Alright, dia consider tu. That's why you boleh only consider convection. Kalau dia open, top, bottom, side, semua open, then you boleh ada convection, conduction and radiation also. Okay, can impact on the heat transfer. So the velocity of air coming parallel, dia kata flowing parallel. This is phase parallel. So airstream tu velocity is 6.1 meter per second and air temperature dia adalah 65.6 degree Celsius. Humidity adalah 0.01. Okay, estimate rate of drying for constant rate period. Okay, rate of drying, constant rate, you boleh pakai equation RC equal to H T minus T wet bulb divided by latent heat. Kalau kita cari time, time equal to LS over A. So you akan ada HT minus TW, latent heat X1 minus X2. X2 of course lah, maximum is XC lah. Okay, so now nak dapatkan RC ni kena cari lah H, nak kena cari T wet bulb. Macam mana nak cari? Okay, kat sini dia bagi tahu. Okay, ni cara dia lah. You kena memang follow this method. So humidity adalah 0.01, dia dah bagi. Dry bulb adalah 65.6. So macam mana nak cari T wet bulb? Gunalah humidity chart. 0.01, 65.6. Mana humidity chart? Okay, this humidity chart. Okay, 65.6, somewhere around here. 0.03 humidity. Right. So this is the intercept. So to get the wet bulb, yang ni paling dekat, ambil ruler, naik atas, draw satu line sampai ujung. So you get the T wet bulb around 30 something. Okay, so dah tahu dah something. Masuklah dalam ni. So you take, oh sorry, 0.01. Okay, sorry lah, saya ingat 0.03. You all pun diam je, rasa you all tidur ni kot. Okay, 0.01, so dia akan dapat T wet bulb 828.9. Boleh cari lah. So dia dah dapat T wet bulb. Okay, bila dia dah dapat T wet bulb tu, macam kat sini dia punya humidity chart tu. Okay, so you dapat kat sini T wet bulb. So you pergi dekat belah kanan pula, ni H wet bulb pun boleh. Boleh dapat. Alright. Dia panggil HW. So dia pergi horizontal line. So this is HW. So dia dapat 0.026. So okay, first nak dapatkan G. Okay, sebenarnya nak kena cari G pasal dalam equation of H, you ada G kan. You tengok kat sini. Ni ada G, ada G. So kena tahu dulu G ni berapa. So G adalah mass velocity. Mass velocity equation dia adalah V times rho. Okay, velocity times density. Okay. G adalah V velocity times rho, density. So density is basically mass over volume, right? So now kena cari volume. And then kena cari mass of air. So macam mana nak cari volume? Dia pakai humid volume. Ni equation yang dah ada, humid volume, VH. VH equal to something and H times temperature. So kalau dalam equation ni ditulis H saja, make sure you pakai H yang diberi. Bukannya pakai HW yang you cari. Okay, kalau dia nak HW, the equation will say HW. Don't worry, dia akan tulis HW. Pasal, why I highlighted this one? Because ada student yang buat mistake. They confused. Tengok equation ni ada H. Oh, this H is what? For H. HW ke H biasa ke? Dia ingat HW. Dia pun bantai HW. Dia dah tulis H je. So that H is basically the normal humidity. Bukannya humidity at wet bulb and so on. Okay, janganlah buat benda complicated. Okay, masuk je nilai dia. Masukkan temperature. in Kelvin. Then you get the volume. Once you get the volume, the volume dah dapat, nak dapat density kena tahu mass. Okay, density is mass over volume. Volume dah tahu, mass. Okay, sekarang ni mass of air. Remember, air is basically consists of dry air plus water. Alright? Mana dapat mass of dry air, mass of water? Okay, you tengok balik dekat humidity. Okay, humidity is basically dia punya unit kat sini ada 0.01 kilo water over kilo dry air. Okay, daripada unit of humidity ni, do you know tak how much water that you have? From here, humidity, you tahu water you akan ada adalah 0.01 kilo. Betul tak daripada atas ni? 0.01 kilo water. Okay, dry air, you ada berapa? Over 1 kilo dry air. So, you ada 1 kilo dry air. So, nak dapat total mass of air, dry air ni plus dengan water. So, dry air 1 kilo plus 0.01 kilo. So, ini you ada 1 kilo dry air, 0.01 kilo of water. Ni daripada mana dapat? Daripada humidity. Okay, humidity Kalau humidity dia bukan 0.01, dia adalah humidity 0.05, let's say. So, what is the mass going to be? It's going to be like 0.05 water plus 1 kilo dry air lah. Jadi, 1.05. Simple je. Dia tengok kepada humidity. And then you divide by volume, you dapat density. Once dah dapat density, bolehlah you gunakan G. V adalah 6.1, rho adalah 1.037. So since dia adalah they are in hour, so you convert lah. Benda ni just conversion, 3600 conversion unit. Alright. Then you dapat 22770. So you check 22770 comply tak dengan yang air flowing parallel. Okay, air flowing parallel 2450 29000. Oh, 27. Okay, comply. Velocity 6.1, comply sebab ni sampai 7.6. Temperature 60 something, so comply. So bolehlah pakai this equation. So pakailah H equal to this one 0.020 times G. So masukkanlah G yang you dapat tadi kat dalam equation ni. So you dapatlah heat transfer coefficient. Alright, once you get the heat transfer coefficient, you pun kena tahu, okay, T wet bulb you dah dapat 28.9. Dapatkan latent heat at wet bulb. Okay, macam ni dapat latent heat? Steam table. Macam ni dapatkan steam table? Ni pandai-pandai kalau you cari. Saya tak nak recap. So, it's not a single column you tahu dapat, tapi dia ada kaedah dia. Okay, you kena buat recap lah benda tu. So, once you dah dapat H, you dah dapat latent heat, you dah dapat T wet bulb, masuk je dalam equation RC. You dapatlah, ini adalah dia punya constant rate, 3.39 kilo per hour meter squared. Alright. Yang lain ni adalah unit yang lain lah, pound and so on. Tapi dalam soalan ni dia saja je tambah. Dia just purposely tambah kalau nak cari total evaporation rate. Remember, dalam constant rate period, dia punya rate of drying is equal to evaporation rate. So dia nak tahu berapa banyak yang water being removed for certain period lah. So, macam nak cari dia? How to get that? Evaporation rate is basically daripada rate of constant ni, you kena times dengan area. Dengan area. So, you akan cancel out area ni. So, you akan dapat berapa per hour. So, RC times area. So, you akan dapat this one. So, total evaporation rate is basically berapa banyak water being removed hourly ataupun second per second ke. So dalam kes ni yang boleh remove adalah 0.708 kilo water per hour. In 1 hour, 0.7 kilo water being removed. Let's say kalau I run dryer ni sampai 10 jam, 10 hours. So cumulative, how much water being removed is going to be 7.8 kilo water being removed lah in 10 hours. Tu kalau dia minta tanya macam tu. Alright? So, okay, clear? On this example.
Ni doktor.
Okay, hopefully everything is move well. Alright, now kita akan move last part. Last part yang kita akan introduce convection, radiation and conduction. Okay. Yang ni kita take 5 dah. Take 5, jadi kita sambung balik kat situ. Okay, so kita continue sikit lagi. Okay, dalam sampai half an hour. Because I also don't feel well today. Ada sedikit cough, apa ni, sesama sikit. Alright, now kita move on kepada, okay, tadi kita dah tengok convection je. So once you understand the concept of convection, now it's very easy to introduce radiation and conduction. So macam mana, how do you have this radiation and conduction? Okay, initially bila kita look into this solid, okay, solid dan juga dia punya on the top here you ada water layer, ada H2O, okay, and then kita zoom in. Bila kita zoom in, kita akan ada like a pool of water dan juga solid lah bawah ni. So ni pool of water ni. So that's why kita akan ada Q, itu adalah Q convection. But we zoom in kat sini. But now kita have to zoom out lah. Sebab kita nak tengok other type of heat transfer. So let's say this is your wet material. So you expose to air here, you ada QC here. So let's say you ada expose both side. Okay, pun ada juga QC here. Okay, sini kat tray. Let's say this is you punya tray. Okay, tray you ni pun, your tray ni, bila heat transfer kepada tray, you akan ada QK, conduction. Okay, conduction akan pergi dekat tray sebab metal, and metal akan transfer kepada solid, wet solid. So dia adalah conduction, solid and solid. Kalau convection, medium dia air dengan solid, so that is convection lah. And then let's say dalam you punya dryer ni, let's say this is you punya big dryer, you ada introduce satu radiation kat sini. So this is radiation, QR, let's say, radiation punya exposure. So dia expose lah pada radiation. So you can ada convection, conduction, even sini convection juga sebab air, and radiation. So you have those three sekali. Okay. So bila you ada semua sekali ni, then you still remember that Q is equal to, okay, Q tadi, kalau kita tengok RC is equal to Q divided by latent heat, okay, of area is equal to H T minus TW divided by latent heat. Okay, ni kalau ada convection sahaja. Okay, but now kita ada yang this is heat heat transfer. Kita ada juga mass. Tapi mass ni kita tak consider. So dalam case ni conduction, convection, radiation. So it's heat transfer. No mass transfer. So, sampai sini lah. So untuk case yang ada semua sekali, ni adalah QC sahaja. So when you have all the others heat transfer, so RC dah jadi apa? Is summation of all the Q divided by latent heat area, sama je. Tapi dia tak pakai W lagi lah, dia tak pakai wet bulb, dia akan jadi latent heat je. So dia akan jadi summation of all Q. Ni summation of all Q jadi apa? Q convection tambah Q conduction tambah Q radiation. Alright, and all of these thing akan divide dengan semua ni akan ganti je lah. So you kena tengok, you kena develop semua equation untuk QC, QK, QR and divide by latent heat area. Okay, ini akan dapat RCU. Okay, you punya constant rate. So you kena tengok satu lah, what is QC? QC is equal to H T minus T. Okay, dalam case ni, bila dia ada, when you have all the heat transfer, kita dah tak pakai dah T wet bulb. Okay, kita akan pakai TS. Kita pakai solid surface. Pasal kita dah zoom out. Zoom out ni kita dah tengok secara big size. So kita tak boleh nampak pun water layer kat sini, whereby kita boleh measure T wet bulb. Tak boleh. So now kita akan assume sebagai TS, T solid surface. Bukan T saturated This is T solid surface. Berapa solid surface tu? So this is equation untuk QC, untuk convection, HC T minus TS times A area. Okay, this is heat transfer lah. Kita dapatkan Q. Untuk QR radiation, the equation HR TR minus TS times area. So HR you boleh expandkan kepada this standard equation. Memang equation ni ada, you belajar heat transfer standard je pakai. Boltzmann 5.576, ni sama je, tak ada beza. Memang pergi chapter lain, you go to other subject, they will not use different equation, they will use the same equation exactly. Alright, so and then you kena dapatkan QK. Dalam QK ni dekat sini lah, kat metal. Okay, but remember that you ada dua, you have two side, this is both side suspended. QC ada dekat atas, QC juga ada dekat bawah. So this QC, dia dah taking account dekat sini, equation ni. Now you akan ada QC kat bawah ni. So QC kat bawah ni, convection, dia transfer kepada metal, barulah dapat QK. So this one dia adalah together dengan metal, conduction. So bila dia together, you akan introduce overall coefficient, UK. Okay, your overall coefficient. Ni you recap balik lah, heat transfer. So UK T minus TS time area. So what is the UK? Is 1 over in series. In series, dia akan lalu convection dulu. 1 over HC, heat transfer coefficient by convection. Barulah dia lalu dekat metal tu. Metal punya thickness, metal punya conductivity plus solid punya thickness, solid punya conductivity. Baru dia dapat overall range daripada convection pergi conduction and conduction. Right? So you dah ada QC, QR dengan QK. So apa nak buat? Macam saya cakap tadi, as I mentioned earlier, so you kena add on. Okay, sebab you tahu dia adalah summation of Q over A latent heat. Now latent heat not at wet bulb. Kalau yang tadi, okay, beza dia dekat sini dipakai wet bulb. T wet bulb, latent heat wet bulb. Tapi Tapi when it's involved conduction, convection and radiation, no longer wet bulb, but rather than dia pakai TS. Okay, so latent heat pun dekat TS surface. So apa you buat? You akan buatlah summation Q ni AK, summation AQ AK dia akan jadi RC equal to summation of Q A latent heat at surface, and this is QC tambah QE tambah QR over A latent heat S. So you masuklah QC apa tadi? HC T minus TS area plus HR T minus TR minus TS area plus ini adalah untuk UK T minus TS times area. Okay, semua ni divide by A latent heat S. So keluarkanlah. Yang mana boleh keluarkan A, boleh keluarkan and so on. So you akan pull aside. Dia jadi macam ni lah. Dia pull aside HC plus UK T minus TS plus HR TR minus HS divide by latent heat surface. A tadi dah boleh cancel out. Pasal semua ada A. So this is basically the equation yang you kena pakai lah untuk dapatkan RC. Okay, but to use this equation, dia ada trick dia. They have a trick. It's not straightforward. Okay, straightforward meaning that you just cannot take any value then you can just use it. No, because T surface here is basically it's not given normally. But if it's given, then it's very easy. You just plug in TS here. Okay, normally it's not given, and you need to do try and error. Okay, dia punya konsep dia. Sebab TS is not given, so you need to do try and error. Try and error maknanya you kena guess nilai TS tu berapa. You have to guess the TS value. First guess, if the TS value is closer to what you guess, then you can use that the one that you calculated, not the one that you guessing. For example, first guess TS you assume 30, let's say, and then you calculate. Macam mana nak calculate? Nanti saya tunjuklah equation dia. TS sama dengan katalah 31. So it's very close, less than 5% error. So you use this one, the calculated, and put it here untuk dapatkan nilai RC. Selagi tak dapat TS yang the correct one, tak boleh guna lagi equation. Okay, so macam mana nak confirmkan the TS is the correct one? Okay, equation bawah ni, the equation below here is basically to test the assumption of TS is correct or not. So how? Macam mana? Okay, yang bawah ni SC divided by KYMB is sama dengan SCS lah. Dia dah bagi dah. Ini sama. Ni 10 times 3 kat sini. So tahu masuk humidity. So here, apa you kena buat? You kena letak TS ni sebagai unknown. You nak cari TS ni berapa. Be calculated lah. So first you kena guess. Okay. You have to guess. Okay, dia punya step dia. You guess TS. Okay. This is first guess. Let's say you guess 30. So kat mana nak guna yang guessing ni? Guessing ni dia akan guna dekat mana yang pakai nilai TS dalam equation yang kat sini, kat bawah ni. Bawah ni, kalau you tengok, okay, dia ada menggunakan HR, HC, UK. Dia pakai UK, dia pakai HR, dia pakai HC. Macam mana dapat HC? HC ni balik semula dekat ni lah. HC you boleh pakai this one. Dia dapat HC. Dia kena tahu G. Dia tahu G baru boleh pakai this. H mana satu. Okay. So, so untuk kat sini, you kena carilah what is the UK. Okay, UK 1 over HC, ZM, KM, ZS, KS. So kalau you tengok, untuk dapatkan HC, you tak perlukan TS punya value pun. Kita recap balik kat sini. Nak dapatkan HC, sini HC, sini adalah HC. You kena tahu G, kena tahu rho, kena tahu humid volume. Humid volume ni memang ada temperature, but this temperature is basically air yang supply, bukannya solid surface. So HC is basically no need TS value dalam calculation dia. So dia boleh calculate terus dapat nilai. Alright. So next, untuk UK tak perlu TS. Right. So HR memerlukan TS kat sini. Then this yang you guessing ni akan masuk kat sini. Nilai TS you untuk dapatkan HR. And then you perlu dapatkan HC dah tahu lah tadi. Alright. So dah dapat UK, dah dapat HC, dah dapat HR. HR ni yang memerlukan TS ni, yang guessing. Alright. So the rest, kat sini you biarkan TS ni sebagai unknown. You biarkan dia sebagai unknown. Sebab you nak dapatkan TS. Nak confirmkan balik. You guess 30. So dalam equation ni, TS ni sebagai unknown. Masukkanlah nilai HS, H, latent heat, S. TS juga diperlukan untuk dapatkan latent heat dekat S temperature. Dan juga HS dekat S, dekat T surface temperature. Tu yang diperlukan pada 30 ni. So bila dah dapat ni, masuk semua nilai, plug in all the value and find TS. Berapa nilai dia menggunakan equation ni. Katalah you dapat, let's say you get from that equation TS equal to 38. 38 dengan 30 is more than 5% error. So then you kena buat second guess. Second guess, let's say you ambil TS in between 30 to 35, you ambil lah 35, 38 kan. So you masuk balik dekat HR ni, nilai yang baru, dan juga dapatkan latent heat yang baru dekat TS yang baru 35, HS yang baru 35. Then you calculate. Okay, you get, katalah you get TSU adalah 34. Okay, 34 dengan 5, closest, less than 5%. Then you boleh pakai, the correct TS adalah this one, yang you get, 34. So apa you kena buat? So now that 34, you include kat sini. Masukkan 34. So this is 34. So HR ni menggunakan TS yang betul, 34. So anything yang kena replace 34 dan you replace lah. Let it hit at 34 and so on, dan dapatkan nilai RC. So this is the way how to find the convection, radiation and conduction lah. RC dia, considering all those heat transfer. Okay, boleh? Boleh ke tak boleh? Boleh lah. Okay, you boleh tengok example. Rasanya yang untuk combine ni dia ada example. I can't remember what is the example 9 something. Probably 9, 6. I can't remember, 16 or 171. So, you tengok balik dalam UB textbook tu. Example untuk considering that they have this all the heat transfer type. Convection, radiation and conduction. and you see how they do this, they did on the try and error. You tengok macam mana dia buat try and error. So then you just follow dia, insyaAllah you boleh faham, you can understand better lah. Like this one I just explaining how to use this equation, how to get what guessing, and when you get the correct one and then you compare. So if less than 5%, you can use the calculated one as you punya next untuk masuk dalam equation untuk RC. Okay? So question?
Doktor,
Yes.
untuk try and error tu kan, usually dia ambil berapa banyak try and error untuk dapat the correct TS?
Saya tak boleh jawab berapa kali. I cannot say how many times. It's basically depending how your guessing punya temperature. Okay, your punya guessing temperature. Let's say, okay, tapi dia ada, they have like a rule of thumb. Bukan rule of thumb lah. I mean from my experience, untuk guess TS ni, normally you kena start dengan what temperature. Okay, you kena start temperature yang little bit higher than T wet bar. Itu dia punya the way that kalau you nak dapat try and error yang tak banyak lah. Sebab let's say lah, katalah dia punya temperature TS tu mungkin dia around 35. Katalah, ni dia punya jawapan lah, katalah. But you first guessing, you guess 50 degrees Celsius. Katalah you first guessing. And then you buat lagi 40. You buat 30, maybe 39. Jadi dia tak closer sangat dengan jawapan. So dia akan ambil 4-5 kali iteration lah. But if you try to guess, normally TS ni, first guessing is little bit higher than T wet bar. Let's say you dapat T wet bar you adalah 29 degrees Celsius. So TS ni little bit higher. You boleh letak 31. So normally kalau you dekat sini starting point, you maybe need another 2 or 3 iterations sahaja untuk sampai dia punya nilai yang closer. Nilai closer tu dia less than 5% error lah. Then you stop lah, no need to guess anymore. Okay?
Okay, doktor.
Alright, so ada lagi soalan lain? Okay, kalau tak ada soalan lain, I'm sorry that there's no quiz for this chapter. Even chapter resorption itu pun tak ada quiz kan. Kita ada dekat crystallization. Kat resorption sahaja. Crystallization tak ada quiz. So it's okay because I know that you are study very hard. You are doing your revision. And if I give quiz, of course you get 100% marks. So no need to have quiz with me, okay, for this particular chapter. So I think Dr. Sharida have more quizzes with her. So, alright, I think that's all for today class. So we're gonna finish our class. I'm gonna finish my lesson until this point. So then Dr. Sharida will continue next week with this. I think she will continue with this through circulation, pet dry, and so on until continuous, until finish the drying chapters. And then she going to continue with the new chapters of membrane and also mechanical, physical separation. But anyhow, if you find any problem arising during your revision or when you try to do some exercise, so you can just text me to ask me on the solution and how. Normally I will not give a solution. Okay, when you ask question, sir, can you give me the answer scheme for this one? I don't have the answer scheme. To be honest, I don't have the answer scheme. Okay, answer scheme is everywhere because the one that preparing the question this last time is other lecturers. So normally they are keeping. Okay, this is moving around. I mean they have a file, but that file is not accessible. Okay, whereby we gather all the answer scheme that particular semester it's a hard copy, so it's difficult for me to get it. For example, to go to the office and then they have like a room that keep all these answer scheme depending on the semester. So I don't have the answer. I probably have answer scheme for my question only, but the other question normally prepared by other lecturer, I don't have it. So that's why if asking me, sir, do you have an answer scheme for this? Normally I will answer. Try to do on your own first, and I will see how do you solve it. If I find that something wrong with it, I will comment on that. Okay, I will not comment on the final answer. For example, exactly the final, what is the correct answer is what? I don't know. Okay, because I don't have the answer scheme. But the way that you solve it is correct or not. That is what I comment. Okay, for example, your step, the step is correct. Or this one seems like you calculated it wrongly. So please calculate again, this one. So I'm going to advise something like that. And then you the one that's going to do it. Okay? So that is how, because if not, if I give just passing you, if I get the answer scheme and passing you the answer scheme, you just might read the answer scheme without doing the exercise. So when you are reading, basically you not learn anything. And then you hope that the final exam, the same question will come up. And because you just keep the answer scheme, and later on you would just want to copy and maybe change some value. But it's wrong. That is mythos, basically. Okay? You try to keep as many answer scheme that you have in your textbook, because you know that it's textbook, open textbook exam. So write down everything in your textbook until you cannot see what the textbook is look like. You know, all the empty space full with the answer scheme. I know. And even you have like additional pages that you stapler your answer scheme there. But please, normally the question will not be the same. Okay, yes, you can have the answer scheme there. But if the question is not the same, how you want to copy that one? No. The thing is, you need to really understand first. Once you understand the concept, whatever the question come up, it's easy for you to solve it. At least, if you cannot solve everything, you have the step to solve it. You already get the marks for the step. Even you not towards the end get the final answer. It's okay. All right? So not solely we depends on the final answer. We're going to look onto the solution. How do you solve it? The way that you solve it, you plug the right numbers or not. Okay, you press your calculator wrongly or what. So we're going to see on that. Okay, at least you have, if not full marks, maybe some marks for it rather than 0 marks. Okay, kalau you ada answer scheme, you ingat answer scheme tu, get a copy and then you thought that it's the same, you try to, satu you tengok answer scheme, macam mana nak jadi sama macam answer scheme? Tak boleh, susah, you akan take time. So lama-lama time consume and then masa habis. Pasal you habiskan masa untuk try to understand first. So that's why you yourself need to understand the topic dulu. You dah faham teori, you dah faham how to solve more or less konsep dia macam mana. If you have question like this, what equation need to be used? Like I did the summary on the drawing. You are the constant, you are the falling. In constant, what kind of method you can use? In falling, what method you can use? From there, you dah summarize kan. When you see the question, you tengok information, oh cukup tak? Tak gunakan method ni. Tak cukup. And then mungkin kena guna method lain. Alright? So then kat situ lah you boleh tahu, oh okay method ni. Then barulah you try buat. Okay? So that is sedikit tips lah untuk you. Alright, so kalau tak ada soalan, if you don't have any question, then I think I will stop now. So thank you very much for your cooperation throughout the 7 week with me. And then hope to see you next semester. Kalau you repeat lah. Kalau you fail, kalau ada yang nak repair ke, mungkin semester akan datang jumpa lagi ke. Alright? Okay, so hopefully that you gonna pass. Alright? Because normally, but now it's a little bit tough. Like starting from last semester, final exam is 60%. Previously, only 40% final exam. So masa tu, kebanyakannya lepas. Yang fail is basically the one that tak submit assignment, tak attend quiz, tak submit project. Dia akan fail lah. Tapi kalau you submit everything, submit project, sit for quiz, submit assignment, normally akan lepas. Lepas tu, it doesn't mean that you lepas tu you get A, B ke. Tak, lepas tu maknanya you get D above lah. C ke D something. You lepas. Sebab failing rate untuk this course normally sangat rendah. Less than 5 or 10 people dalam